the topic which we are going to start today is vernier calipers. Now, it is just a measuring instrument, alright, but it gives you more accuracy than your normal scale. Usually its accuracy is up to 0.01 centimeters. Alright, I'll come to that later, but before you understand it properly, it is very important to discuss its construction. Through that, I'll explain how to use it, okay. So, firstly, I told it is made up of two different types of scales. First type, in the construction, if you will see properly, there is one main scale, and that main scale is very much similar to the normal scale which you all use. Alright, so divisions are marked from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your, from here till here is 1 centimeters, and from here till here is 1 millimeters. Now this one is your main scale. These divisions are your main scale divisions, and this is your main scale. On top of the main scale, there is another scale, something like this, which you can slide over the main scale. Alright, now this one you can just slide over the main scale, and it is provided with a small box like structure here. Now, through this box you can actually see the scale, the readings which are graduations which are inside. So this, from 0 to 1, then understood? Now, so this one is your vernier box, or you can say the vernier scale. Again, on this blue scale, again markings are there from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions are marked. Now these all are your vernier scale divisions. So this is your vernier scale. Ten divisions are there, and depending upon the instrument, sometimes they have from 0 to 20 also. Alright, at the end, because it would be too long, I am just putting a break mark here to draw the rest part of the main scale. Alright, from 2 it is continuing, and this is the last division. At the end you will see a metallic strip. This is your metallic strip. This side on the main scale you will find on top one jaw is there. This is one jaw, and this side another jaw is there, something like this. This we will call it as J1, and on the vernier scale also you are having one jaw, something like this. This is your jaw. Here also you are having one more jaw. So this is your J1, J2, J3, J4. So this one is your external jaws. External jaws, and these ones J2 and J3 are internal jaws. Now this instrument helps you measure more accurately than 1 millimeter, because your normal scale it measures up to 1 millimeter, but it will allow you to measure much more accurately. There are lots of things which you can measure. If you want to measure length or diameter of any substance, you will just place it between these two jaws. Suppose a rod is there, you can just place it here. So you can find the length of the rod, or even if you want to measure diameter of a sphere, you will place the sphere here. You can calculate the diameter of sphere. If you want to measure the internal diameter of a hollow cylinder, all you have to do, you have to place that hollow cylinder here. That means two jaws will be inside at the mouth of the hollow cylinder. Now if you want to measure depth of anything, of a beaker for example, you will put this metallic strip into that beaker. So there are various things which you can measure from it, and many other things you can do from it. Alright, I hope all the functions are clear. So if I ask you what are the functions of jaws J1 and J2, the external jaws to measure the length or diameter of any substance, the functions of internal jaws J3 and J4 to measure the internal or external diameter of a hollow cylinder, Metallic strip helps you find the depth of anything. All right. Now, after this, next topic is the principle on which it is based. So, to understand the principle, I'll just draw this box, okay. If you look carefully, I'm just drawing the main scale. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions are there. You count it, 10 divisions are there. But on the vernier scale, you look carefully, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. 10 divisions are finishing here. Just a little correction. From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. On main scale also 10 divisions are there. On vernier scale also 10 divisions are there. But if you look carefully, the 10th division of the vernier scale is coinciding exactly with the 9th division of the main scale. That means we can just write 10 divisions of vernier scale is equal to 9 divisions of main scale. If it was an instrument having 20 vernier scale divisions, suppose here 20 divisions were there, then the main scale division should be 19, coinciding exactly with the vernier scale. It simply means that if I take n divisions in the vernier scale, on the main scale there should be n minus 1. Here it was 10, 10 minus 1 is 9, here it was 20, 20 minus 1 is 19. So, if there were 10 divisions here in the vernier scale, the number of divisions which will be coinciding or equivalent to those n divisions would be n minus 1. So, that is the principle of the vernier. It states that n divisions of vernier scale is always equal to n minus 1 divisions of the main scale. So, that is the principle. If you want to take reading, stepwise we will do it. First step, to take the reading using a vernier calipers or slide calipers. Step 1. Step 1, you will check for the errors. Check for error. Alright, how to check? First thing what you will do, you will make sure the both the jaws are in contact like this. J1 and J2, you bring them together. After this, you check for the 0 mark of the main scale and 0 mark of the vernier scale. If they appear to be like this, even after both the jaws are coinciding, if the 0 mark of the upper and lower scale, they are not coinciding, that means the instrument is having an error. If the 0 mark of vernier scale is on the right hand side, see here, this is on the right hand side, this 0 mark of the main scale, that means the instrument is having a positive 0 error. So, in this situation you are having positive 0 error. In order to find that error, the formula is division coinciding into least count. Alright. Now, how to find the division coinciding? All you have to do, you have to check for the division of the vernier scale which is coinciding exactly with the upper scale. Suppose upper scale is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and lower scale again 1, 2, look here, I made this coincide 1, 3, 4, 5, 6, 7, 8, 9, 10. So, as you can see here, the third division of the lower scale, the vernier scale, is coinciding exactly with the upper scale. So, your answer would be division coinciding is third and least count is 0.01. That would be 0.03 centimeters with a positive sign. This is how you find positive 0 error. But if the situation was something like this, the upper scale 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, and the lower scale, the 0 mark is on the left hand side and both the jaws are coinciding, J1 and J2. If this is the situation, the upper scale you see 0 mark is here, and lower scale, the Vernier scale, is on the left hand side. That means the instrument is having -0 error. To calculate -0 error, a different formula is there. Minus total Vernier scale divisions minus division coinciding into least count. This is the formula. So negative sign, total number of divisions in the Vernier scale, we know that it is 10. Alright, so 10 minus division which is coinciding. Suppose again 1, 2, 3, suppose fourth division now is coinciding. You see here, fourth division is coinciding with the upper one. So I am writing here 4 into least count 0.01. So that would be minus 6 into 0.01, that is minus 0.06 centimeters. This is your -0 error. Second step, step 2. Step 2 is finding the main scale reading and Vernier scale reading. Alright, this time between the jaws J1 and J2, you will put the instrument or the substance of which you want to measure the length. Suppose I am placing one iron rod here. Alright, so this time the jaws are not coinciding with each other, but something is there. And suppose the reading here is showing like this. On the main scale 0, let it be 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, that is 5. Alright, and 0 mark is suppose starting from here of the Vernier. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this. Alright, in order to calculate for the mean scale reading, the formula is, or directly you can calculate it. All you have to do, you have to check for the main scale reading now, which division of the main scale is lying just before the 0 mark of the Vernier scale. This is the 0 mark of Vernier scale, and the division which is just before it on the main scale is 4th. So main scale reading is 4 into 0.01. Directly you will write 4 centimeters. That is the reading on the main scale. If you want to calculate the Vernier scale reading, again the formula is division coinciding into least count. So in this case, Vernier scale reading, the division of the Vernier you check. This division on the lower scale you check 1, 2, 3, 4, 5. Fifth division of Vernier scale is coinciding with the main scale division. So according to the formula, division coinciding is 5th and least count is 0.01. So that is 0.05 centimeters. So this is your Vernier scale reading. Step 3. Step 3, observed reading. Observed reading, very simple, you just add the main scale reading and Vernier scale reading. So formula would be main scale reading plus Vernier scale reading, add it up. So main scale reading you got 4 centimeters, Vernier scale reading was 0.05, so that is 4.05 centimeters. Alright, and lastly, the final step, step 4 is the corrected reading. Now this step you will apply only if there was an error in the instrument. Alright, the formula would be observed reading minus 0 error with sign. This is the formula. Alright, for example, suppose this instrument in step 1, suppose the error, for example, it was minus 0.02 centimeters. Suppose this was the error. Alright, so how to calculate the corrected reading? Observed reading is 4.05, minus sign is there, but you have to place the value of 0 error with its sign. So because the error I am taking is -1, inside bracket one more negative sign would be there, 0.02. So this would be 4.05 negative plus 0.02, so that is 4.07 centimeters. So that is your final answer. Suppose the error was positive, then simply you will write here plus 0.02, and according to that your answer will come.